Hi, welcome to my channel Harita. Today we are discussing about AMBA protocol. AMBA protocol stands for Advanced Microcontroller Bus Architecture. It is a communication protocol used inside a SoC to connect CPU, memory and peripheral. It is widely used in ARM-based chips. Main AMBA protocols: AXI, AHB, APB. AXI means Advanced Extensible Interface. It is high-speed communication used between CPU, memory, DMA, GPU. Supports bus transfer and multiple transaction. AHB, Advanced High Performance Bus, medium high-speed bus used for processor and memory connection. Simpler than AXI. APB, it is Advanced Peripheral Bus, low speed, lower power bus used for UART, GPIO, timer, SPI peripherals, simple to read and write transfers. What is AMBA? AMBA, it is a Advanced High Microcontroller Bus Architecture developed by ARM Holdings. Open standard for communication, SoC communication. Connects different blocks inside a chip. Defines communication rules between components, widely used in processor and embedded system designs. Common AMBA buses are AHB, APB, AXI, used for different data transfers inside SoC. Why AMBA? Provides technology independence, makes designs reusable across different systems, supports modular design approach, enables creation of reusable component libraries, reduces repeated high design work, minimizes silicon area for communication, improves on-chip and off-chip communication efficiency. It is an AMBA-based microcontroller, so all the high-performance devices will be connected to an AHB bus and the lower power peripheral connected to an APB bus, and bridge access and interface between just high performance inputs and low power peripherals. So this converts the AHB transfers to equivalent APB transfers, and bridge is an AHB slave and the APB master. Let's start with AHB protocol. Features of AHB: high-speed data transfer, supports multiple bus masters, pipeline operation for better performance, bus transfer supports single clock edge operation, separate address and data phase, supports large data weight transfers, efficient for processor and memory communication, centralized arbitration for bus access, suitable for high performance SoC design. AMBA signals: H clock, H reset, H address. It is width is 31 down to 0. H transaction 1 down to 0. H write, H size 2 down to 0. H burst 2 down to 0. HW data 31 down to 0. Additional AHB signals are HR data, that width is 31 down to 0. H ready, H response 1 down to 0 with the H transaction description. Here we have 1 down to 0, means we will get combinations 0001 1011. 00 indicates ideal, 01 indicates busy, 10 indicates non-sequential, 11 indicates sequential. H burst. Here we have with 2 down to 0. We will get 2 power 3 means 8 combinations we will get. 000 indicates single transfer, 001 increment burst, 010 4-bit wrapping burst, 011 4-bit incrementing burst, 100 8-bit wrapping burst, 101 H-bit 8-bit incrementing burst, 110 16-bit wrapping burst. 111 16-bit incrementing burst. H size, its width is 2.0. Transverse size 000 means 8-bit, it is a byte. 001 H 16 bits, it is half word. 010 32 bits, word, it is word. 011 64 bits. 100 128 bits. 101 256 bits. 110 512 bits. 311 1024 bits. This is AHB architecture. So here all the masters and slaves are connected to an interconnect. So interconnect will have a components like arbiter, mux, decoder, etc. So at a time only one master and slave can communicate with each other. So whichever master wants to perform transaction on the bus, first it has to send a request to the arbiter. So based on the arbiter mechanism, the arbiter will give grant to any one of the master, and arbiter will provide the select signal to address and write data mux. So based on the master whichever got the grant, only that address and data, the write data signal only from the particular master will be reaching slave, and there will be a decoder which will generate the slave selected decoder and the address sent by the master and its generate select signal for slave, and the same select signal will give as an select input to the read data mux. So now whenever slave is sending the read data, only the slave which has been selected, so only the read data will reach the master. So like this is interconnect will take care of the fair data access between the master and slave. Simply here first send request to the arbiter and will give grant, so only the particular master the granted access will perform a transaction with slave. Based on the address of slave, decoder will decode the slave, and only that particular slave will participate in the communication.